6 months ago, a bank in Southeast Asia deployed an AI-powered access review tool. It was fine-tuned on last year's entitlement data. That AI-powered tool confidently approved a toxic combination, finance plus admin access, because the model had no idea the segregation of duties policy had changed 3 months earlier. The audit finding cost the bank 4 weeks of remediation and a regulatory notice. That's not a prompting problem, that's an architecture problem. And today, I want to give the framework to get that architecture right before it costs you. RAG or fine tuning? Let's settle this from an enterprise architect's point of view. Most explanations online oversimplify whether to choose RAG or fine tuning. So here's the clean, enterprise friendly version. RAG is about facts, that's to the core. RAG gives the model access to your data. It doesn't learn anything permanently. It retrieves, it reads, it summarizes on demand every single time. Fine-tuning is about behavior. Fine-tuning changes how the model thinks, writes, and responds. It shapes instincts, tone, format, and reasoning patterns. Here's the first big correction, and most people get this wrong. Fine-tuning does not make your model more accurate for facts. It actually increases hallucination when used for factual recall. RAG is more accurate for facts because it reads the source every time. Forget the open book exam analogy. Here's one that resonates with architects and security professionals. RAG is like giving a smart engineer a library card. They don't memorize everything in the library, but they are excellent at finding the right document, reading it quickly, and giving you an accurate answer, sourced, traceable, and current. Fine-tuning is like sending that engineer to a specialized school. You are not giving them more documents. You are changing how they think, how they communicate, and what instincts they develop. But here's the catch. If they learn something wrong during training, you can't patch it with a memo. You have to send them back to school. That's the architectural difference. One gives you access to current truth. The other shapes how the model behaves with whatever truth it finds. RAG is the right choice when your data changes frequently, when you need auditability, when you need permission-aware answers, when you need to show the source document, and when hallucination is a compliance risk, which in banking, finance services, and insurance, it almost always is. Here's the identity and access management IAM example that makes this concrete. Imagine you want an AI assistant that answers questions like, what entitlements does user X have in SailPoint right now? Show me the last 10 CyberArk Vault access logs for this account. Which Active Directory groups changed in the last 24 hours? These datasets change every minute. Every access grant, every vault checkout, every group modification is a new data point. You cannot fine-tune a model every time a user gets a new entitlement. That's not architecture, that's chaos. You need RAG. Because RAG reads the live data on demand. It doesn't guess, it retrieves. Fine-tuning wins when you want to change behavior, not knowledge. Specifically, tone, style, output format, reasoning patterns, domain-specific vocabulary, and internal naming conventions. Here's what that looks like in an identity and access management IAM context. If you want your model to write bean shell rules in your organization's internal coding style, that's behavior, fine-tuning. If you want it to generate SailPoint certification workflows that follow your team's naming conventions, that's behavior, fine-tuning. If you want it to produce CyberArk onboarding templates that match your exact format every time without you having to prompt it, that's behavior, fine-tuning. The pattern is consistent. Behavior is fine-tuning. Facts are RAG. Keep these two lanes separate in your mind and the decision becomes simple. Let me give you a clean side by side. Purpose. RAG handles facts, fine-tuning handles behavior. Data freshness. RAG is real-time, fine-tuning is frozen at the point of training. Hallucination risk. RAG is low because it's grounded in a source document. Fine tuning is higher because the model guesses when it doesn't know. Transparency. RAG is high. You can show the user exactly which document the answer came from. Fine tuning is a black box. The model's confidence doesn't tell you where it got the information. Cost. RAG has a low ongoing cost once the pipeline is built. Fine tuning has a high upfront cost, and every time your policies, formats, or data change significantly, you're looking at a retraining cycle. Security. RAG is strong. You can enforce role based access control (RBAC) or attribute based access control (ABAC) at the retrieval layer. So users only see documents they are authorized to access. Fine tuning is weak for security because the training data is baked into the model weights. You cannot untrain sensitive information once it's in there. Maintenance. RAG is easy. Update your data source and the model automatically gives better answers. Fine tuning is hard. A policy change might require a full retraining run. Here's what the industry is actually doing in 2026. Leading banks and Global Capability Center (GCC) technology organizations aren't choosing between RAG and fine tuning. They are running both in a layered stack. The pattern works like this. You use parameter efficient fine tuning (PEFT) or low rank adaptation (LoRa). These are lightweight fine tuning techniques, not full model retraining, to teach the model how to behave. Your format, your tone, your internal naming standards. Think of it as onboarding a new analyst to your team's style guide. You do it once, it's relatively cheap, and it doesn't need to know every current entitlement to be useful. It just needs to write the way your team writes. Then you use RAG to supply the facts. Today's SailPoint entitlement data, today's CyberArk vault logs, today's AD group changes, live, sourced, auditable. You add guardrails for compliance, especially important in the Reserve Bank of India (RBI) regulated environments or under India's Digital Personal Data Protection (DPDP) Act. And you add identity and access management (IAM) enforced permissions at the retrieval layer, so the model only surfaces data the requesting user is actually authorized to see. In a BFSI environment, this is not optional. This is the solid architecture. Fine-tune behavior, RAG grounded facts, compliance guardrails, IAM enforced access. That is what a production grade enterprise AI system looks like in 2026. Let me leave you with 3 questions. Answer these honestly and the decision makes itself. Is your question about what the model should know? Build a RAG pipeline. Is your question about how the model should behave? Use fine tuning. Specifically, lightweight parameter efficient fine tuning (PEFT) or low rank adaptation (LoRa). Do you need both? You almost certainly do. Build the hybrid stack. That's it. No hype, no buzzwords, just the framework. One can adjust the weights on the hybrid scale for both of these methods according to the needs of specific enterprise or group. If you're building AI systems in an IAM or BFSI environment, this decision is one you're going to face, probably sooner than you expect. I've spent more than 1.5 decades in this industry. Mainframe, identity governance, access management, BFSI security. And the pattern I keep seeing is teams reaching for fine tuning when what they actually need is a well architected retrieval pipeline. Usually because fine tuning sounds more powerful, more intelligent, more AI. It isn't. Not for facts. Not in a regulated environment where every answer needs to be traceable and every access decision needs to be defensible. Get the architecture right first. The model is just one layer in that architecture. If this was useful, subscribe. Every video on this channel is built for practitioners. Identity and access management, IAM architects, security leads, GCC technology teams. People who need to make real decisions in real environments, not just understand concepts in theory. And if you haven't watched the previous episode on how RAG actually works, watch that next. It will make everything in this video even clearer. I'll see you there. Until next time, thank you.